Hi, so we'll continue with the third technique, conjoint analysis. So what happens in conjoint analysis is uh, instead of collecting data cognitively like we used to in, let's say, regression as well as factor analysis, where we are asking people to, we're asking them a statement and then we're collecting data on each statement. Here we try to simulate the actual purchase environment for the user. So over here with in a choice-based conjoint, what we do is uh, we make models of products, which we call concepts. So in a concept, there will be multiple attributes. So let me explain. So in class, I was talking about cameras, right? So let's say we are making two concepts for two different cameras. And in a concept, we will have attributes like brand name, uh, lens type, uh, focus, uh, charging point, whatever. So there are 4 or 5 attributes like this. So what are these attributes? These are variables. And each attribute will have levels within them, which are nothing but the value of the variable. So there are some good practices like how many uh, attributes should be there in the concept, how many levels should be there per attribute and all that. So we'll get to that. But the basic point of conjoint analysis is to be able to understand or rather quantitatively give an output as to which particular feature of a product or which particular attribute of a product is uh, more important than other attributes, or let's say which particular level of an attribute is more favored in the market as compared to other levels of that attribute. So let's say, do people prefer black cars over red cars? Do people prefer uh, color of a car over the brand of a car? So these are the kind of inferences that you can get out of conjoint without asking questions directly, but rather giving them replicating a purchase environment for them and finding out what would they choose over what. So it's basically called a trade-off exercise. And one of the most common examples of this is a brand price trade-off, which often cigarette brands do, because there is not much to analyze in a cigarette. It's just, let's say, a brand and a price. That's the two things that a customer will take into account while purchasing a cigarette. So to find out whether brand is more important than price or price is more important to the consumer, or let's say which brand is more important, like which brand is more favored to the customer, that's what you can do with the concept. So what they will try to do is we are going to try and analyze and think that yeah, so the decomposing the overall judgment of a customer. So the judgment is basically the choice of a customer that we are trying to break down into several attributes and levels. And how we will do that is we are going to assign them some numbers, which are called part worths, and we'll calculate part worths for each level of each attribute, and then we'll sum up those part words to find out the utility, or that which is basically the sum of all the part words of a particular concept. And whichever concept will have the higher utility, we will try to say that that is more favored over the other. So that's what that's what conjoint analysis is. uh, yeah, so these are some underlying theories. You can look at this. It's better to look at it from here because it's written very simply than go to Naresh Malhotra for this part, especially. So yeah, the trade-off exercise that we spoke about, so important. Products can be broken down into its component. Yeah, so this is one assumption that the features that we are the or the attributes that we are taking into account uh, can cumulatively form what the product basically looks like. So we are assuming that purchase decision of a car can be broken down into the components of a car, which could be brand name, color, body type, transmission, so on and so forth. And then once we are, if the value of individual component to a consumer can be measured, then the value of complete products can be computed by reassembling or adding up the component values. It's pretty intuitive. Yeah. So there's a type of conjoint, single card and multiple card. Single card is basically one product is shown to the customer. Multiple is where there are more products and you basically have a rank data over there. So these are not what we have done so far in this course. What we have done is choice-based conjoint. And choice-based conjoint is where you are showing them multiple options at one point and recording what they're choosing and what they're implicitly not choosing or what they're choosing over the other. Adaptive conjoint analysis is kind of like a GMAT of choice-based conjoint where you predicting or you're basically studying what the respondent is responding, and on the basis of that you are giving him or her the next choices. And partial profile concept is where suppose your profile of the concept is too huge, you have too many attributes. So you may choose to cap the number of attributes that you show to the to a particular respondent, so as to not make, let's say, like, yeah, so uh, let's say you have 30 attributes, so you have one product and you have 30 attributes to look at, and you don't want the respondent to get fatigued or anything, so you can cap it at like 5 attributes or 10 attributes uh, to get a more efficient or more uh, this thing, like a more fair understanding of what they want. Yeah, so how do we make the conjoint design is first we have to figure out what are the attributes and what are the levels within each attribute. Then we are collecting the data. We are calculating the utility by understanding what the part words are. And then based on the basis of that, you are conducting some analysis and you're doing some data modeling, which we'll get into one by one. So yeah, these are the kind of choices you will have to make when you're creating the design stage of the uh, conjoint. Firstly, you will have just a second. Yeah. Yeah, so the number of attributes will decide, then you will decide the number of levels, then you will decide the type of conjoint that you're going to use. Uh, then something you might take into account is sample size, and all of these will be used to calculate what we will call the efficiency of the conjoint design. We'll come to that. And so in the software which we use, I think Sawtooth software. So over there we basically had to measure. We had to mention how many cards will be there. So how many cards as in like how many different choices will the respondent need to make. So let's say we say there will be 8 cards. Now we have to decide how many products or how many concepts will be shown on each card. So it can be that with each card you might show 3 products, like we did in our conjoint assignment. So uh, that will decide basically on what basis you are choosing. So there can be 2 cards, there can be 2 concepts on each card, there can be 3 concepts on each card, and every concept itself will have the number of attributes that you will define, and every attribute will have the number of levels you will define. So it's basically like an algorithm. You can start with the number of cards, the number of concepts in the card, and how many attributes in each concept, and how many levels within each attribute. All right. Mm. Yeah, so how you will decide on what the sample size will be on the basis of this efficiency uh, formula, where basically you are this thumb rule that you have n into c into o by t is greater or equal to 500 is basically going to make sure that your conjoint analysis is efficient enough. So the number of respondents you can increase to as many as you want, and that will indefinitely keep increasing your efficiency of a conjoint of the conjoint design. So I mean there is no upper limit to it, right? So as long as you're crossing 500 over here, it's fine. The number of concepts shown on each card, number of cards shown to a respondent, and maximum number of levels in an attribute. There are some constraints onto it, which beyond which it will become a little problematic for the respondent to even fathom कि इतने सारे options हैं मैं क्या करूँ इसका. So number of concepts is usually, I think, three. 2 to 3 is a good number of concepts. Number of cards shown to respondent is 8 to 12, and maximum number of levels, I think it's 2 to 5 or something. But one thing you have to keep in mind is that the number of levels of each attribute should be comparable. It shouldn't be that one attribute has 7 levels and the other attribute has 2 levels, or like even wider disparity, because there is something called the level effect, which basically we'll try to understand in the analysis segment. Just hold on to that thought. Um, yeah, so there is another thing called constraint or the prohibition. So what you do in prohibition is you tell the software that do not show this particular concept with this particular uh, combination of attributes and levels. So what suppose you are analyzing Apple and Android mobile phones, and your one attribute is your operating system, and for the iPhone you have Apple, and for Android you have for let's say Samsung you have operating system uh, Android. So one thing you know for sure is that for an iPhone you will never have Android as an operating system. So if you want, then as a researcher, you can eliminate this before running the analysis. So you can eliminate this combination, that phone type iPhone, operating system Android will never be shown in your conjoint design if you uh, put that as a prohibition. So that's what a constraint means. Uh, Yeah, so this is used to uh, preemptively remove all the erroneous combination, which will never be possible in a real world situation. So yeah, and so the data collection process can happen basically through the, like we said, rank or anything, which we never did. And the second thing was when you are doing in a choice-based conjoint, you can either do it in through two methods, choice and chip allocation. The choice is something where you are selecting only one out of n number of choices that you have. And chip allocation happens when suppose you have a limited number of resources of chips and you are asked to allocate it to different all the different choices that you have. So say suppose you have the question asks you to purchase a singular unit of a computer and you have three options, then you will follow the choice. So you will just say, I will select this one to buy. But if they say that you have to buy 5 computers and these are your options, which one will you buy and how many? Then you can allocate those 5 chips that have been allocated to you as like maybe 3 to 1 or however many. You can give 5 chips to one particular uh, choice as well. So that's how it goes. So yeah, so radio button is basically a choice task. So you are selecting either one of these choices. So each of these are concepts. So this combination of Dell 2.8 gigahertz and 1500, this is one concept. This is two concepts. There are 4 concepts in one card. So yeah, so if you have to look at it this way, so this is one card which will be shown. It will have 4 concepts. Each concept will have 3 attributes, and these attributes, you can assume that the first attribute is brand name, the second attribute is processor, and the third attribute is price. So every uh, attribute will have a particular number of levels. Over here, you can see 3 levels of brand, Dell, IBM, and Compaq. And uh, the attribute of processor is like 2.9 gigahertz, 3 gigahertz, 3.2 gigahertz. So 3 more levels of this, and 3 prices, 3 different prices. So now if you're asked to choose, then you will have to choose one. Okay, so none, I wouldn't choose any of these, is just like, it's just there. So this is not a part of the concept. So I think there are 3 concepts in this card. And constant sum or chip allocation happens in this way, where Okay, so you have allocate 10 points, so you have to buy 10 PCs, uh, and you will basically allocate the number of PCs you want for each of these options. Yeah, so we come to the main part, which is your utility calculation. So how is the data calculated or how it is captured, let's say. So here you will have to bear with me. It might get a little confusing, but just uh, stay on track. It's basically one singular way of understanding. It's a linear way of understanding. Once you get the hang of one equation, everything else will become simple. So in logistic regression, or forget logistic regression, basically when you're understanding choice, it's always in a binary thing. So either your choice is 0 or your choice is 1. So when your choice is 0, usually it is no. And if your choice is 1, usually that is yes. So let's say if you have product 1, 2, and 3, three choices to make, and you select product 1, then automatically the value of this product will become 1 and the rest 2 will become 0. What I mean by that is, if you are plotting it in a sense of a regression equation, then there will be an independent variable which will be a function of these three dependent variables. So brand will be a dependent variable, price will be a dependent variable, color will be a dependent variable. All of these will be a part of a logistic regression model for an independent variable, which is y, or y is the choice. Now, whether your choice is 0 or 1, if there was a radio button here and you clicked on that radio button here, then that means that your y value is 1, means you selected product 1, and the rest 2 automatically becomes 0, automatically will be recorded as 0. But so that's how the data is recorded for a choice. Now, okay, brilliant. So it's written over here. So suppose the respondent chooses a second product. Cool. So how are we writing the three products in equation form is in this way. So you have said that the second product has been chosen, right? So you write three equations, whatever these equations are. You can see that the second product is 1 over here, where y should be y equals to alpha plus beta 1, blah, 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 whatever is there. Y is 1 in product 2 only, and automatically product 1 and product 3 have recorded 0 in the choice. Correct. So alpha is a constant. We are not using it anywhere. And the rest, how are we doing it? Is that, let's look at this first variable, brand. Brand has three levels, right? A, B, or C. So this particular part of the equation represents brand. So you can see that there is a beta 1, there is a beta 2, there is a beta 3. These are coefficients of each of these singular levels of a brand. If you have remembered dummy variables, which it was taught in class, this is what the idea of a dummy variable is. So when I had said in my regression video that you cannot run regression on a non-metric scale data, you need to convert non-metric data into metric data. This is what it meant. Brand A or B or C is a non-metric, it's a nominal scale data, but we are converting it into dummy variables, which are beta 1, beta 2, beta 3. Let's call this variable A, B, C. If you're calling this variable A, B, and C, what happens is you are selecting one for only that particular variable. Let's say 1 in beta 1 correlates to brand A, right? So in this particular situation, among these three dummy variables, only the one which correlates to A will be recorded as 1. The one which correlates to B will be recorded as 0. The one which correlates to C will be recorded as 0. Similarly, for the second product, in the second equation, look at the same three just look at these three. The one that equates to A will be recorded as 0 because product 2 is not A, right? Product 2 is B. So the one which is correlated to B will be recorded as 1. And since it is not C, then the third option, the third level will also be recorded as 0. For product 3, it is the same. Beta 1 0, beta 2 0, beta 3 1. Why? Because this beta 3 1 is correlating to the level C, right? The word C. So when brand level is C, then beta 3 will be recorded as 1 and the rest 2 will automatically be 0. So that's how that's how a metric scale is formed out of a non-metric data. Whether brand will be A or B or C will be measured in this format. The fact that product 1 brand has A will mean that these three things will come into the equation: beta 1 1 plus beta 2 0 plus beta 3 0. The fact that product 2 has brand B and not A and not C but brand B will be recorded as beta 1 0 plus beta 2 1 plus beta 3 0 because it's not A, it's not C, it's B. Similarly for product 3, it's not A, it's not B, it is C. For product 1, it is A, not B, not C. That's how brand is been recorded. Just this level, this attribute is recorded in three variables. If there were another variable, a brand D, then there will be another beta 4 plus beta 4 into 0, beta 4 into 0, so on, so on, so on, so forth. That's how it will go on, right? And similarly, see, price is recorded as a metric variable. So here you don't need three variables separately. It's just mu into 5, mu into 7, mu into 9. Why? Because it's recorded in one, like it's just a metric data. So mu is the coefficient. Either it's 5 or 7 or 9. So product 1 it was 5, product 2 it's 7, product 3 it's 9. But again, color is a non-metric data, non-metric red, blue, red, black, and green. So once again, we have uh, three different independent variables, dummy variables. Once again, to show that color is red, we will write YA1 plus YB0 plus YC0. To show that the color is black, we'll put YB as 1, the rest will be 0 because this is not. These two are not. This is 1. Then A is 0, B is 0, C is 1 because it's the third option, green. So that's how this entire data is recorded. And based on this data, uh, these are all regression equations. So that is what your logistic regression is. Please make sure that you don't confuse this with logit. Logit is something totally different, which will come later on. So logistic regression, because it's binary, so that's how you are capturing the data of a conjoint analysis. If this is clear, then okay. So one drawback of using regression is that number of attributes and levels in if okay. So the number of attributes and levels, if it's too large, then utilities cannot be attained at an individual level. So that is one drawback. If they ask you what is a drawback, you can write this. Hence, utilities are calculated aggregate level, which in turn, yeah. So this is the rectify thing. I don't think इसमें मैं समझा पाऊंगा कुछ. But yeah, this is important. If you have to find out कि कैसे हो रहा है, that's how it's calculated. And yeah, so based on this data that you have calculated, the zeros and ones, after doing all of this, you can you can understand four different things out of all this conjoint. So first being uh, your average part worth. So this basically the part words that are calculated are of every level of every attribute that you are doing, right? Just see if I'm missing out on. Yeah, so part worth is basically the quantitative value that a respondent associates with a level of an attribute. So, uh, just one second. Yeah, so how these part worths are calculated is basically you have to rescale the coefficients of different levels within an attribute, and the rescaled coefficients will all add up to zero. Okay, so the coefficients that we just calculated here, all of these will be rescaled within each attribute. So within this attribute, the coefficients will be rescaled and the sum of them will be zero. And the result will be what the coefficient will be used to calculate the part worth. So when you are running it in the software will give you the part worths of each level of each attribute. And now these part worths will be telling you basically कि ये ज़्यादा important है over like this particular level of an attribute is more important than the other levels of that attribute. That's what the average part worth will say. Relative importance. So relative importance is something you can understand by the range of the part words. So let's say you have taken brand size, sorry, brand size, brand name, and you have part worth ranging from uh, -2 to +2, and you have taken color where your part worth is ranging from -5 to +5. So that essentially you can help to understand, like the larger the range of a particular attribute, you can say that relatively color is more important to the consumer's choice. The color of the product impacts the consumer's choice more relatively as compared to the brand name. That's what relative importance is. The preference share is something which we all calculated in the assignment, right? So it was that pie chart. So basically, it indicates the, like, in a market among all the concepts that exist, what kind of like what is the current uh, preference of the consumers towards the particular concept that you have chosen. By concept, I mean all the combination of all the attributes and levels that you have. What is the preference of that over others? Once you have calculated once you figure that out, you can, if you can build that simulator, what happens in that simulator is you can change the uh, levels of each attribute to find out कि तुम्हारा preference share बढ़ कैसे रहा है या घट कैसे रहा है. So that is what we call a what if analysis. So we find out all the existing concepts in the market, we put them one by one, and we calculate the preference share of each concept in the market. Then we say that what if we change our level of this attribute to that level. So, for example, suppose I am a Mercedes-Benz manufacturer and I only manufacture black cars, and I'm finding out that people have more preference towards white cars. So, what if I introduced a white car? How would the preference share change in the market? That is what the what if analysis can help you with. And market share is nothing but you are multiplying your preference share with the volume of sales of a company. So market share is something we didn't calculate in our assignment because we couldn't. And so basically it's a weighted measure of the preference share, and the weight is the sales. So how much money you are making in the market. So yeah, here are some important points about part words where basically their part words are in interval scale. And what interval scale is means that if there is a part worth of 2 in one product and a part worth of 1 in the other, you cannot say that 2 is twice of 1. You can say that 2 is 1 point more than 1. You can say that let's say 3 is 2 points greater than 1, but you cannot say that 3 is thrice of one, because there is no singular zero. There is no absolute zero from which it's ending. It's all referential. Okay, so interval scale supports addition, subtraction, but does not do multiplication, division. It is not appropriate to say that part worth of one is twice. Okay, yeah, just said that. Okay, so you cannot compare one level from one attribute with one level from another attribute. You can only compare levels within each attribute. So you can't say that black color is more important than 2000 rupees as a price. You can only conclude that 5000 is less important than 2000 rupees as price, and red is more important than black as such. You can't do cross attribute comparisons like that. So yeah, it's just a pictorial version of what we just spoke about. You can go through, like if you want to go through further understanding, you can refer to Naresh Malhotra. There are really good pictorial representations of that. So yeah, this is what the part words look like basically for respondent one, for each brand, for brand attribute, these are the each of the levels, and for each level, these are the part words associated with each respondent. And this is like size is one attribute. These are the levels: 5 liter, sorry, yeah, 5 liter, 7.5 liter, 10 liter, and these are the part words. Right, so that's what the output will look like, and you will be able to say that yeah, drop door is more important as compared to swing door as per respondent one. And also, yeah, one more thing is that the data will be collected on a respondent level. So we have to calculate overall, then you have to take average of all the respondents data for every level of every attribute. Right. So yeah, relative importance is like you can find out which is the max value, which is the min value in the range. And once you have calculated the range, so whichever level, whichever attribute has the highest range in the total, in so this they have taken in percentage terms. So they've added all of these up, and they've said that this is 26%, this 22%, this 29%. So this particular attribute has a higher importance as compared to other ones. But this is only possible to say because it's percentage, it's relative. You can't say that objectively this is more important as such. Um, yeah, so there were two things. One was first choice model and the other was logit model of share understanding preference share. So first choice model takes into account that जिसका भी utility सबसे ज़्यादा होगा, like you add up all the part words of a particular combination and उसका जो utility होगा उस concept का, if that concept utility is the maximum, then that is the first choice and that is the only choice that the consumer is going to make. Logit model, on the other hand, takes into account some exponent value something. Basically, I think I've written it down. So yeah, so model is basically where you're taking the exponent value of a particular variable and dividing it by the sum of the exponent values of all other variables, all other products. Yeah, so these are some assumptions. इसको रट्टा मारना पड़ेगा. There's nothing else to do. I don't think it's that important over here. Yeah, this was all basically assignment related stuff. I'm pretty sure he's not going to ask us to make a simulator. So yeah, that's pretty much it. Conjoint analysis. If there are any other doubts, you can ask me later on. I'll answer them. And we'll move on to cluster analysis in the next one.